Hello everyone, we are doing lead code 1128 number of equivalent domino pairs. So it says given a list of dominoes of I is basically a pair of two numbers 1 comma 2, 2 comma 1, so on and so forth. Dominoes of I is equivalent to dominoes of J, CD if only A equals C and B equals D, or if it's the other way around, if A equals D and B equals C, right? That is, one domino can be rotated to be equal to another domino. And we saw from yesterday's problem of the day, what does it mean to rotate a domino, right? A domino has two sides, so a top side and a bottom side. So if you rotate the domino, the top side becomes the bottom and the bottom becomes the top. It says return the number of pairs I comma j for which this, and basically return the number of pairs where dominoes of I is equivalent to dominoes of j, and both of I and j are sort of, j is bigger than I, so you're not talking about equal indexes obviously, and both I and j are valid valid indices. So of the first approach that comes to my mind is going to be a brute force one, right? So if I take a screenshot of this and paste it over here, then the brute force approach is something going to be like this. So I sort all of these individual arrays, right? I sort all of these, so it becomes 1 comma 2, 1 comma 2, 3 comma 4, and 5 comma 6, and then I just iterate. So for this I check this, both of these are equal, so my answer becomes, from 0 it becomes 1. Then I check this, nothing happens, check this, nothing happens, so on and so forth. Then I increment my I, start the j from at this point, nothing happens, so on and so forth. So that's kind of, you know, the very brute force approach that I can take. And if I do the same thing for the second example, let's see if it works or not, right? So if we take the second example and if we do the exact same thing, let me just do this. So if we take the second example and if we do the exact same thing, right? So it's going to be, if I sort first of all of these arrays, and what you would notice is that they are already sorted. So yeah, I'll sort all of them, and then I'll start my I from over here, I'll start my j from over here. My answer is initially 0. Both of these match, so I'll increment it by 1, then increment. Then when I'm at this point, answer becomes 2. Then increment, nothing happens. Then I increment my I, start j from here, nothing happens. And when I'm at this point, the answer becomes 3, and then nothing happens. So similarly, I increment my I, start my j pointer from here, and carry on the same procedure again and again. So if we do this inside of our code, if we do this inside of our code, how is it going to look like? Let's see. First of all, I'm going to calculate what nums dot size is. Nums, basically I have renamed the dominoes to nums, and then I'll start from int I equals 0, I is less than, I need to go till n minus 1, right? Because the last one is going to be covered by j. So I'm going to start with I by I plus 1, just like I was doing in the dry run. J is less than n and j plus plus, right? I will go till the very last. So for each index I, I'm seeing all the other j's. So yeah, chalo, even before this, I need to sort each and every individual nums array, right? So for int vector int and percent I in nums, just sort all of them. Sort I dot begin, I dot end. So that's what it's going to do, is it's going to receive each and every vector, each and every individual vector by address, and it's going to sort all of them, right? Okay, this works. Then what do I need to do? I need to initialize int ans equals 0, right? And whenever I have nums of I equal nums of j, so I'll say something like this: ans plus equal if nums of I is equal nums of j, right? And in the end, what I will do is just return the whatever the answers. So if I run this code, it's going to pass the example test cases, right? But then overall, it's going to give me a time limit exceeded error. Why? Because this is clearly an O of n square approach, and at maximum the dominoes length can be 4 into 10 to the power 4. So if I take 4 into 10 to the power 4 and if I apply a square over here, it becomes equals to what? It becomes equals to 16 into 10 to the power 8, which is actually 1.6 into 10 to the power 9 is greater than 10 to the power 8, right? So it's going to give me a time limit exceeded error. Let's see if it really gives me a time limit exceeded error or not. According to our calculation it does, but let's see if it gives us or not. Okay, it indeed does give us, and the last test case is actually not passing. So 18 out of 19 test cases are being passed, the last one is not being passed. That basically lets us know that we need a better approach, we need to do something better. So where is the redundancy, what is the redundant part, how can I capture the redundant part and make it you know less redundant, how can I optimize this approach? Let's think about it. So what I'm really doing is, for this particular I see all of these choices. Then for this particular again I'm seeing these choices. Why do I have to repeat this? I have already seen this 3, 4 and 5, 6, right? Why am I seeing them again? If I'm over here, I have already seen all of these choices for this Then when my eye reaches this point, I again see all of these choices. Why do I need to repeat seeing them if I have already seen them at one point? Isn't it? So one thing which is coming to my mind at this point is, why don't I sort all of these arrays so it becomes 1 comma 2, 1 comma 2, 3 comma 4 and 5 comma 6, and why don't I take a map of pair of int comma int comma int. So what basically I'm doing is I am counting the frequency of each pair after sorting. So what's going to happen is the frequency of 1 comma 2 is going to become 2, the frequency of 3 comma 4 is going to become 1, the frequency of 5 comma 6 is also going to become 1, right? In this scenario, what's going to happen, the frequency of 1 comma 2 is going to become 3, actually 1, 2 and 3, it's going to become 3. The frequency of 1 comma 1 is going to become 1 and 2 comma 2 is going to become 1. Now the thing is, how do we actually count the pairs? You see, if I have just one pair, then the answer is 1. But then when I have 3 of the same things, the answer is 3. Why is that so? I'll explain it to you in a very simple way, in a very simple way. So you see, when you have 3 of the same things, so that is basically for this particular number, you have 2 same things. So this particular index makes 2 pairs. Okay, 1 pair and 2 pair. So 2 pairs. And then this particular index, it just makes a single pair. So 2 plus 1. Alright, I had the frequency 3 and it told me 2 plus 1. I just had one pair, so that was just a single one. For example, let's say I had 1 comma 2, 1 comma 2, 1 comma 2 and 1 comma 2. Then this pair would have had made 3 pairs, this would have made 2 pairs, this would have made 1 pair, and the frequency would have been 4. So what is this actually? This is the sum of natural numbers, isn't it? The sum of the first n natural numbers. But then the thing is, this is not the sum of first 4 natural numbers. This is the sum of 4 minus 1 natural numbers. So basically what I'm trying to say is, whatever the frequency that you have, you need to then calculate the frequency of first n minus 1 natural numbers, and whatever that comes out to be, you need to add that in your answers. For example, if I had 1 comma 2 over here as well, I would have added to my answer what? The sum of first 3 natural numbers, which is 3 plus 2 plus 1, which is 6. Makes sense? But since right now I have just 3, so I will add 2 plus 1, which is 3, and that is actually my answer. So I need to do that for each and every frequency. So for the sum of first 0 natural numbers, the sum of first 0 natural numbers, the sum of first 2 natural numbers, which is 2 plus 1, 3. That is what I need to do. So let's do that inside of our code. We are going to sort each and every array. We are going to take answer as 0, and then we are going to take a map. We are going to take a map of pair of in comment, comma int, because we are keeping the track of frequency of each of the pairs. Then what I'm going to do, and since I'm sorting, I can actually why use another loop. Let's just do that inside of here as well. So I'll take the map at the very start. I'll shift the map to the very start, and I'll just use the same loop in order to calculate the frequency as well. So I'm going to say MP of the pair, and before that, let's actually do this something like this. So A would be equals to I of 0, and B would be equals to I of 1. Okay, and I'm going to say MP of A comma B, just increase its frequency, right? Everything makes sense till this point. I'm keeping track of the frequencies, and then what I'm going to do is I'm going to iterate over the map for auto row in map, and I'm just concerned with the frequencies, right? So frequency would actually be row dot second. So if I'm only concerned with these. I'm not concerned with the actual pairs. I'm only concerned with the frequencies. And what do I need to do? I need to add to my answer what? I need to add to my answer the sum of first n minus 1 natural numbers, where this is actually your n. So what I'm going to do, how do we, by the way, how do we calculate the sum of first n natural numbers? That is n into n plus 1 divided by 2. This gives you the sum of first n natural numbers, but we are saying that our n is actually n minus 1. We don't need the sum of first n natural numbers, we need the sum of first n minus 1 natural numbers. So this n is going to become n minus 1, and n minus 1 plus 1 becomes n. So n minus 1 into n divided by 2, that is how I'm going to get the sum of first n minus 1 natural numbers. Let's do that. I'm going to say ans plus equals frequency minus 1 into frequency divided by 2. That's it, and then I return my answer. So if I run this test case, it is, if it passed the third case, test case, which was giving me a time limit exceeded error before, and obviously it's going to pass all of the test cases as well. So if we look at the time and space complexity over here, then what we are doing is we are taking a map in order to store all of the pairs that we have. So that's clearly O of n extra space, but then the time complexity is reduced. The time complexity is no longer O of n square, it's clearly O of n, because I visit each and every index just once, right? While actually keeping track of the frequencies, I just visit them once, and then the rest of the thing is just I'm iterating through whatever the size of the map is and adding the respective things to my answer. So the time complexity and space complexity, both of them are O of n. This was actually a very good question, a very good practice of how maps are used, and I hope you found the video helpful. I will see you in the next one.